In this video, I am going to comparison with the confidence interval. So instead of doing a hypothesis test, we could take the value of p hat and form a 95% confidence of interval. This would be similar to conducting a two-tailed test at 5% significant level. Remember, this is two-tailed test. Because if you think about it, your hypothesis test is built around a null hypothesis, which is p hat. For a two-tailed test, you're basically looking for these two value. And this, since this is symmetric, these two areas should be the same length from the null hypothesis. So that means you're constructing a 95% confidence of interval. So what you're looking for here, the p-value, which is if it's 5% significant levels. Okay, so now let's take a look. If the proportion from the null hypothesis is in the interval, we fail to reject the null hypothesis. That means the proportion from the null hypothesis is inside interval. We fail to reject it. If the proportion from the null hypothesis is outside, we reject the null hypothesis. Okay, so now, I think this is very common. When we look at statistics, you see a long paragraph, and then you got panic. So what's important is we need to identify what is this number for. What does this number mean? We got 13.5%, 70, 228, and 13.3%. Okay, so 13.4%, they say, hey, for CDC in 2008 is something that we don't need to use. The CDC report that 13.4% of the adults in the United States are obese. So that means this is going to be our population proportion because it's the whole US. So the population proportion, P, is equal to 0.34. And then a county healthy services planning and new awareness campaign pulls a random sample of, so this is a sample, right? So that means your sample size is 750. In this sample, 228 people were found to be obese based on their answer to a healthy questionnaire. So that means our sample proportion of obese should be 228 people out of 750 people. Do these responses provide a strong evidence that 13.4% figure is not accurate for this region? Now, construct a 95% confidence of interval for the proportion of these adults, and how does this relate to the confidence of interval? First of all, our null hypothesis, P. Oh, right now it's confidence of interval. We don't have null hypothesis or not null hypothesis. We got everything number that we laid out. And to start with a confidence of interval, we need to start with a central limit theorem. We want to prove that, hey, everything is independent and is randomization. Also, the success and failure condition. We also need to check that. So n times p, 750 times the population proportion is greater than or equal to 10. 700 times 0.66 also greater than or equal to 10. So that means the success and failure condition are met. So now we can construct our confidence of interval for proportion. So first of all, our mu is going to equal to the proportion, the population proportion, which is 0.34. And then our sigma proportion is equals to P times Q over the sample size and take square root. So this is equal to 0.0173. All right. Now the next is, how do we construct a confidence of interval? Confidence of interval is built around the proportion, right? So build around the sample proportion, so it should be p hat plus or minus the z-score times p times q over n, which is the standard error. Okay, so p hat is equal to what? Well, our p hat is the sample proportion, which is 228 people out of 750 people. Consider that they are obese. So this is equal to 0.304. Okay. So since this is a 95% confidence of interval, so z-score is equal to 1.96. All right. So we substitute everything in. We have 0.304 plus or minus 1.96 times, this is standard of error, which is happens to be our sigma, 0.0134. Okay, so this is approximately equal to 304 plus or minus 0.329. 0.039. Oh, sorry, it's 0.339. So I calculate that. So I got this confidence of interval, which is 27.0% or 33.79%. Okay, so this is our 95% of confidence of interval. So now let's take a look. So 13.4% of the adult reported in the United States have that. So 13.4 is not inside the confidence of interval, right? So that means based on the 95% confidence of interval, our null hypothesis is 13.5% is outside of the confidence of interval. So we reject the null hypothesis. So there is evidence that for the alternative hypothesis, whatever that is. So this is very similar to the two-tailed test when it comes to the hypothesis test. So if I use confidence of interval, here is the proof with confidence of interval. Now, I am going to show you how to use a hypothesis test to run this test. I'm going to erase this part from this part. Okay, so to set up these, we need a null hypothesis. So the null hypothesis, what is the current result right now, which is 13.4%. And then the alternative hypothesis is not equal to 13.4%. Remember that this is going to be a two-tailed test. That means your p-value is going to multiply by 2. Central limit theorem, we already checked it before, so I'm not going to do this again. Now, the next step is, after we check the central limit theorem, we need to set up a sampling distribution of proportion. And in here, you already have the sigma and the mu for the sampling distribution of proportion. All right. So now, what's the next step? The next step is we're trying to see if p hat, in our case, p hat is equal to 13.4. So this is going to be A on the left side of the proportion, but your final result, you need to multiply by 2. So we know that the Semlon distribution proportion is going to look like 0.34, and then each time you add 1 standard deviation, 2 standard deviation, and the 13 point, your p hat, which is 13.4%, is going to be on the right side, on the left side, and then your p-value should be times 2 of this area. So when we use a GeoGebra, we want to type out the p-hat less than 13.4%, given the p-hat is follow a normal distribution with mu equals to 13.4%, and the sigma is 1.3. 0.0173. Now let's take a look. Oh, sorry. All right. So we have 0.73, and then this is 0.17, and then x is less than. Okay, so what we got is 0.0187. So this is 0.0187, and our p-value should be 0.0187 times 2, which is 0.0374. In this case, our p-value is less than alpha, which is 5% of significant level. So that means p-value is small. So we reject the null hypothesis because p-value is small, with the p-value equals to 3.74%. There's evidence for the alternative test. So either way works. You can construct a confidence of interval to prove that the hypothesis test, or you can use a two-tailed hypothesis test to prove your null hypothesis. Okay, so that's it for the comparison with the confidence of interval. Let me know if you have other questions.